Good morning, ladies and gentlemen, and thank you for coming to my talk. I would like to thank the organizer of the conference, Environment, Technology and Energy, for giving me the opportunity to share some information with you. And my apology because I was unable to come to attend to do this presentation physically at the conference. The title of my talk is Electric Vehicle to Support Electricity Network During the Peak Demand. And the objective of this talk is looking at the current electricity grid structure, weaknesses with current grid and need for smart grid. Electric vehicle is becoming a new component of the grid. Benefits of electric vehicle as part of the grid. And finally, some research questions. I'm sure there are some research students amongst the delegates, and then conclusion. My talk actually consists of two parts. Part number one is about a smart grid, and part number two is about electric vehicle. And I have used the list of sources I have used to prepare this presentation for you. Part one, smart grid. As you can see, currently electricity is generated in bulk and in central power stations and travels through high voltage transmission line to medium voltage transmission line and then to the loads. And as you can see, there are some new technologies, solar photovoltaic and wind farm are connected to distribution network. But electric vehicle is now coming to become a part of electricity grid to help the grid and to actually support the grid to change some improvement or positive impact. Electricity grid and the important role of electric vehicle integrated into the smart grid environment is investigated. About the grid, one of the world's largest and most complicated and sophisticated system is electricity grid, but is old and outdated. Even in the developed countries, millions of people without power for a couple of hours every day. Recently, the number of weather-caused major outages have increased rapidly because these facilities are outdoor facilities. Even in the countries with modern power grid, the only way utilities know there is a power outage is when a customer calls and reports it. The grid has to be able to handle thousands of generators of different technology and different sizes, as well as supplying electricity to millions of customers in a reliable and sustainable way. A smartphone, for example, means a phone with a computer in it. A smart grid means fully computerized electricity grid. This doesn't mean that we have a dumb grid. A smart grid includes adding two-way digital communication technology to the devices associated with the grid. A key feature of the smart grid is automation technology that lets the utility adjust and control millions of devices from a central location. The concept of a smart grid has been around for many years. Important for us is to understand what is really meant with smart grid and how a smart grid can contribute to national electricity policy. The question is, what do we want from smart grid to do cost effectively? One of the key features of a smart grid concept which is challenging is involvement of the customers, customer engagement in the process of current network structure. The other aspect that a smart grid is challenging is the use of information communication technologies at all levels. Current grid structure, as you have seen before, It's electricity is generated in a central power station and travels through transmission lines to the load. And traditional power network can be described as they are centralized and controllable generation but uncontrollable loads. Generation follows the load. Power flows in only one direction. Power system operation is mainly based on historical data and experience. Overloads in the system is detected by the operators. Rerouting of power flow in the case of overload is performed by the operators. Utilities do not have sufficient information about the grid conditions. There is a high power loss, and likely events are costly power blackout. In future, in near future, that central power station still will be the main power generators, and we will see more and more renewable energy sources connected to distribution network. Innovation in power industry is to make grid smarter, and drivers for this innovation are economics, environment, climate change, clean technology, energy efficiency, national regulatory, and security of supply. What is a smart grid? There is no uniform definition of a smart grid. According to European technology platform, a smart grid is an electricity network that can intelligently integrate the actions of the users connected to it in order to efficiently deliver sustainable, economic, and secure electricity supply. According to U.S. Department of Energy, the smart grid is a self-healing, enabled device, participation of customers, accommodate all generation and storage options, enable introduction of new products, services, markets, optimize asset utilization, and operate efficiently, provide reliable power quality for the digital economy. And according to Australian government, a smart grid combines advanced telecommunication and information technology applications with a smart application to enhance energy efficiency on the electricity power grid in homes and in business. What we expect from a smart grid? Electricity systems worldwide face a number of challenges. They are relatively old, in some countries 60, 70 years old, and demand is growing continuously, and shifting load pattern and reliable renewable based power supply. In the past, grid operators had to contact with substation via telephone. And present grid distribution control system, they contact substation via computer. And in the future, there will be sensor and computer at any corner of the grid in order to provide full information about the operation of the system to the operators. What is a smart? A smart is when the power company know exactly where a power failure happens and quickly fix it. Extend life of equipments, detect the missing outage by sensing potential equipment failure, reducing power loss, and a smooth power demand to take advantage of off-peak supply. Maintain a sufficient, cost-effective power supply while managing greenhouse gas target. Make it easier for customer to use renewable energy sources. Use meters that show consumers the energy use in real time. And use variable pricing that allows customer to choose off-peak energy. And help customer to establish a smart home that turns appliances on and off. And customer-side application of a smart grid, consumer cannot be expected to manage what they cannot measure or see. So there is lack of visibility. A smart grid overcomes this lack of visibility, making real-time usage and pricing data available through in-home displays, online portals, smartphones, and then consumer can identify energy-intensive appliances that they have at home. And demand management method helps consumer to reduce energy use during peak time, showing the need for investment in costly generation, transmission, and distribution infrastructure, improving reliability and reducing the overall cost of supply, and etc. And utility side benefit of a smart grid is better manage their grid, customer choice, understanding energy usage, reduce cost of electricity, communication with appliances, and using renewable energy, and integration of electric vehicle. Self-healing. A self-healing smart grid can provide a number of benefits that lend to a more stable and efficient system. Three of its primary functions include real-time monitoring and reactions, anticipation, which enables the system to automatically look for problems that could trigger larger disturbances, and rapid isolation, which allows the system to isolate part of the network that experienced failure from the rest of the system to avoid the spread of disruption and enables a more rapid restoration. As a result of this function, a self-healing smart grid system is able to reduce power outage and minimize their lengths when they do occur. The smart grid is able to detect abnormal signals, make adaptive configuration, and isolate disturbances, eliminating or minimizing electrical disturbances during storms or other natural disasters. International collaboration and investment on a smart grid. As you can see, there is actually collaboration between the countries in relation to smart grids. In America, in Europe, almost everywhere. And billions of dollars is invested in a smart grid, as this figure shows. Principles of a smart grid technologies. You know, a power system, electricity network, has many different sections: generation, transmission, distribution, industrial, service, residential. As you can see, the smart grid technology is applicable in all of them. For example, integration of renewable energy and distributed generation, or integration of information communication technology in all actually sectors have applications. Part two of my presentation is electric vehicle. An electric vehicle is defined in this talk as a vehicle with an electric battery that can be charged from the network, plug-in hybrid and battery electric vehicle to home or vehicle to grid. The battery-powered electric car has been around for more than 100 years. In 1990, out of a total of less than 4,500 cars produced in the United States, nearly 30% were battery-powered. This picture shows a German electric vehicle in 1904 with the chauffeurs on top. And this figure actually shows Thomas Edison and an electric car in 1913. Electric vehicle was overshadowed by petrol engine, availability of gasoline, and limited range of electric vehicle, which is considered as disadvantage of electric vehicle. And electric vehicle came back in 1990s because a driver for this coming back was high cost of petrol, incentive for low emission vehicles, battery performance improvements, and decrease in the cost of battery. And this actually shows the timeline of electric vehicle. In 1859, the lead acid battery was actually invented. And Thomas Edison in 1879 installed electric lights. The first electric vehicle built in the United States in 1891, and the first commercial available electric vehicle in US was in 1897. And after that, it didn't take much seriously, but in the Second World War, because of the shortage of gas, some countries, European countries, and also Japan, they start using electric vehicle. In 1996, General Motors begins leasing the electric vehicle one of the several electric brands rolled out to meet zero emission rules. Nissan Leaf came to the market in 2010, and 2011 the Tesla Roadster came to the market. Disadvantage of electric vehicles: high cost, relatively high, and low top speed, and also short range. And all these weaknesses are improving. And in 1990s, the electric vehicle came back because of a rising petrol cost, advancement of battery technology, and need to reduce emissions. This is a picture of Nissan Leaf in the United States in 2010, and this car is available also in Australia. This is electric car manufactured in South Korea by Hyundai. This is actually electric car and charging station. This is a real picture, it's not Photoshop. And electric car are charged by solar energy, solar photovoltaic. As you can see, transportation 100% free of emissions. This is UK electric car, and this is also Chinese version of electric car. The battery is 75 kilowatt hours, and the range is 195 kilometers. And this is Tesla Roadster, and popular electric car which does not use gasoline, is named after the father of alternating current, Nikola Tesla. The battery size is 53 kilowatt hours, and range is about 244 miles or 393 kilometers. And this is a Tesla car is being charged. So simple. And this is a Japanese Mitsubishi electric car. Very nice, very quiet, and very roomy, although the car is very small, but inside is very roomy. And this is GM car, electric car, 3-phase AC induction electric motor, and lead acid battery. And this one is Nissan Leaf. Battery size is 24 kilowatt hours, and range depends on the model. Yeah, it changes from 117 and goes up to 200 kilometer. And this one is German BMW. Battery size is 22 kilowatt hours, and range is up to 300 kilometers. A benefit of electric battery for the grid. From the grid point of view, electric vehicle is considered as an electrical device representing a new demand for electricity during the period that electric vehicle needs to be charged. But they can play a role of storage device that could supply electric power back to the grid. Through an effective communication with the grid, electric vehicle battery can be used as a storage device that can make the electricity grid more reliable, especially with the large proportion of renewable energy, such as grid-connected solar and PV and wind. Benefit of electric vehicle: as electric vehicle as a mobile distributed energy storage device can help the grid during the period that grid is facing high peak demand. Electric vehicle batteries would help shifting the grid load from peak and busy time to a less demand time, help smoothing the variation in power generation by variable sources such as solar and wind, save money in the long run through effective electricity management. This is actually one example of load profile, and the red one shows the load profile in summer, just as an example, and the green one shows the load profile in winter. And electric vehicle or battery storage can help and shift the load to a later time, from busy time to a less busy time. Challenges: cost of electric vehicle is relatively high, but its time will be actually reduced with the time in future. Range of limitation, as we can see as we go, the range of electric vehicles that produced these days are much higher than 10 years ago. Safety and reliability, progress through research and development, and driving adaptation through education, educating the drivers. Opportunities: government fundings for research will help for technology advancement and cost reduction. International research, development, and demonstration, cooperation, coordination can help address common areas of need, accelerate technological breakthrough, and consumer education campaign and clear fuel economy labeling can help enhancing public awareness, and many other opportunities. Research questions. Research questions are: how significant is importance of charging and discharging of electric vehicle in electricity demand? Is the existing distribution network infrastructure capable of handling the increase in demand associated with the widespread of electric vehicle uptake? What is the best method of charge management? How will the extended range of electric vehicles such as Tesla and Nissan Leaf impact on customer charging behavior? What cost can be expected for consumer charging electric vehicle on existing distribution network? And as a consequence, how will the consumer's ability to exploit time of use rate affect electricity demand? What benefit can smart technology provide in reducing the impact of electric vehicle charging? Understanding vehicle use profiles, electric vehicle benefits, and battery life challenges. Increasing renewable energy sources like solar and wind with vehicle charging. Developing and testing a grid interoperability standard. Exploring grid services technology opportunity. And many other research questions. Wireless technology, communication, electric vehicle system, monitoring and sense and control of charging, software systems for electric vehicle energy management, smart charging infrastructure, electric vehicle fleet management technology and services, vehicle to grid, vehicle to home. This is happening in Japan. Smart charging infrastructure and scalability, environmental issues and benefits, energy management, role of renewable energy in electric vehicle integration, power quality, reliability, and stability effects as a result of electric vehicle, customer adaptation, customer behavior and customer response, pricing model for charging station roaming across territories. And in conclusion, considering electric vehicle batteries as distributed storage in a smart grid environment, some of technical issues that we need to deal with, energy management and control strategy in integrating electric vehicle into the grid is the key to using electric vehicle as distributed storage and needed to be carefully examined. We need to understand the control and management issues when thousands of people plug in their electric vehicle to the grid. we need to realize that at some point during the day, the local utility might experience a deficit of electricity. Before begin charging, the electric vehicle batteries need to communicate with the utility to determine if there is spare capacity in the system to begin charging the battery. So we need an intelligent inverter. I finished my presentation with these two actually slides that I have borrowed from one of my colleagues. This actually shows a house in Australia. As you can see, the car parked in front of the house, and electricity is generated by central power station. And electricity travels in one direction only, from the generator to the load. And in future, the location of car will be different, comes closer to house. Central power station is still there, but house has solar panels for electricity generation, solar hot water system, and there are some wind farm supplying electricity to the grid. And then electricity will actually travel in two directions, from the grid to the house, and also from the house to the grid. And also it's solar, car is closer, car is electric car, and solar panel is supplying electricity to the electric car. And at the same time, car can actually supply electricity to some devices like air conditioning in the house. Thank you very much for your attention. I would like to ask the organizer of this conference provide a copy of my PowerPoint slide for your reference. Thank you very much and good luck.